Okay, 7-5, this is for the 6th period class because I am gone during your class period, so I'm videotaping. Parallel lines is the key for this section. Okay? Hey. Oh, yeah, we forgot to say hi. Hey, 6th period. Okay, parallel lines is the key for this section. When you have parallel lines, you, in some cases, can make a proportion.
Oh, yeah, sorry.
What does a proportion look like?
Two things.
Two, like basically two fractions, something equal to something, right?
X over y equals z over.
Sure, x over y equals z over w, right? And then you set them up and you cross multiply and divide, right? You set it up like that.
Thing is AB equals AE.
Right,
BC,
right,
BD.
right. Okay.
I got it wrong.
So it's going to involve parallel lines. What tells you in this diagram that those things are parallel?
The triangle.
These little arrows, okay? Those are going to be the key symbols in this case that tell you that those things are parallel to each other, okay? Let's go through and label this. It says that ST is parallel to RQ. Do you see that symbol right there?
Sure.
Yeah. ST is parallel to RQ, but they've also labeled it with the triangles here, or the little arrows. Mm-hmm. Label some things. PT is 7.5. TQ is 3, that little distance there. SR is 2.5, and they want to know PS, so that's what we're trying to find, okay? Now, in past sections, what we would do is we would separate, don't draw this, but we would separate this out into two pieces. We would have 7.5, we would have X, and then we'd have a bigger one, and this would be like 10.5. Mm-hmm. What would this side be, the other side? If we call this guy X. Yeah, X plus 2.5 or 2.5 plus X, right? And we would set up a proportion that way. But in this section, what they're telling you is that because these lines are parallel, we can get away with just doing like X over 2.5 equals 7.5 over 3. And the reason for that is because those things are parallel. And only because they're parallel. Okay? So, do that really quick. Do your cross multiply and divide by yourself, and then I'll jump in after I get this going for right.
You got that.
There you go.
Okay, did I finish my print test?
I don't think so.
I think I have like one left.
Okay. Okay.
Here, what is 2.5?
What is that? Somebody give it to me.
26 and a 4.
No, I'm totally just kidding.
Ooh, what?
Is it 26? I have no clue what it is.
I know, that's
2.5, 7.5.
No.
18.7.
Why did I put 3?
Okay. I can divide that by 3.
It's because I put 3.5.
You can divide that by 3 in your head.
I bet you get 6.75.
2.5. 6.25 is what X is, but is that what they were asking for?
No, X plus
They're asking for PS,
plus X.
which we literally labeled as X, right?
Fast for Kelsey.
Okay, so PS is literally 6.25, and that's good. Okay? Good? So, no longer gone are the days where we have to separate them out and do a big triangle and a small triangle, as long as those lines are parallel. Okay? You still have to do that for the previous sections where they're not parallel. Okay? Good? Moving on down here, determine if they're parallel. So here we do not know that DE and GH are parallel to each other. We do not know that. Okay? We are trying to label things and see if they're parallel. So EH, it says how long is EH? 3. HF, this must be F down here. It got cut off. Okay, label him as F down here, there at the bottom. Is 9. And then it says DG is 1/3 the length of GF. So this guy is 1/3 of what this guy is. They don't give us numbers. They don't give us numbers.
1/3 X. 3.
Okay, yeah, so let's pick some numbers. What if this guy is 2? What would this guy be?
6.
6, because this is 1/3 of that. We can make up numbers if we want to, right? Okay. Now, how do we determine whether these two guys are parallel to each other?
Bro, what?
If you do a proportion, then they're equal.
2 over 6 equals 3 over 9. Is that true?
Nope.
This guy is 18. This guy is also 18. Okay. So, yes, they are parallel. Yes, DE is parallel to GH. Okay. Now, again, they said DG is 1/3 the length of GF. So if you're just running a test, just make up some numbers. We could have done 1 and 3. We could have done 3 and 9. We could have done a bunch of different ones. 4 and 12, right? 1/3, as long as these are in the relationship of 1 to 3. Okay? All right. It seems rigged. Okay, the mid segment of a triangle. We've talked about mid segment before, but it had to do with trapezoids. Do you guys remember that last chapter?
No, because yeah.
Okay, this mid-segment of a trapezoid right here.
Sure.
Okay. He's like right in the middle. That's the mid-segment of a trapezoid. Going over here to the mid-segment of a triangle. Okay, this is what the mid-segment looks like. Okay, he has some unique qualities here. Ready? Watch this. There is really kind of a bunch of triangles in there, actually. This line right here, RP, is a mid-segment. And he's a mid-segment because he separates this side into two equal pieces. Do you see that? He's splitting him in half.
Yep.
Okay? And P is splitting this guy in half. Those two are two equal pieces. Okay? So it's the middle of the sides and it's just connecting them. Okay? Now, if it's the middle of the sides connecting them, what's the relationship between this line and this line? They are parallel to each other. You see that? Those two guys are going to be parallel. When you're connecting the mid-segments, those two guys are going to be parallel. Okay, I'm going to erase. And let's talk about this line right here, PQ. No, just wait. PQ. P is the middle of this side. Q is the middle of this side because they have 3 tick marks. So we did middle to middle. And what's true about this line to this line?
They're parallel.
They're parallel. Okay, the last mid-segment that we have is RQ, which is this guy right here. Okay, middle here to middle here. Which line is he parallel to? AB, this one right here. Okay, so they are parallel. The mid-segments are parallel to the opposite sides. Does that make sense?
Yep.
And it makes like a little triangle in the middle, which is kind of cool. Okay, let's go on and answer some questions on the next page. Flip over to the next page. Okay. They kind of made this look a little bit funny. Look at this diagram right here. They kind of made this look a little bit funny because they're doing the mid-segment here, XZ, this guy. He is going to be parallel to this bottom side. You see that? Those two purple ones, okay? Now I'm going to do this one. This XY, he is parallel to this one right here, right? Okay? They did not draw the third one in. Do you see where the third one should go?
Yeah.
This one right here. That one they did not draw in there. He should be parallel to this guy. Okay, now, one more thing.
Oh, were we not supposed to draw that one?
You can if you want to. Number 1, let's talk about mid-segments. Here are some things that you need to write down about mid-segments. The 2 things that you need to remember. They are parallel to the opposite side, and they are half the length of the opposite side. Okay, so not only are they parallel to the opposite side, the side that they're parallel to, but they are exactly half of the length of what the opposite side was. Okay, so we're going to go down here and label some things. So write those down. This is kind of like your cheat sheet for how you determine mid-segments. Okay, good? All right, beautiful. Okay, XY, this length right here, how long is that? 7. So what other length can I determine and how long is it? 14 is which one?
Blue.
ST. This length from here to here has to be 14. Do you see that? If one is half of the other one. Okay, now we also have another thing labeled. What else is labeled?
13.
This is 13 right here. So what else can I determine?
6.5.
What's 6.5? XZ. This guy is 6.5. Right?
So
it's going to be half of that. Okay?
Okay.
So now we have that stuff going on, right? Let's figure out what we're wanting. They want us to label XZ. Do we have XZ labeled? 6.5. We already have that labeled. 6.5. They want ST
14.
is 14. Okay, now they want angle RYX. Which one is RYX?
That triangle.
That one.
Like this angle right here. What the heck?
They're opposite interior.
Okay. This is what Mallory said. I'm going to go in green. We want to know this angle right here. Check this out. Watch this line here and this line here. Those guys are parallel, and this is called a what?
Transversal.
Transversal, and we're talking about this angle versus this angle. They are alternate interior angles, so that is 124. Do you guys see that?
Yeah.
Okay, alternate interior angles because they're parallel, right? So 124 degrees is what that guy is. Okay, we could go through and map out this little figure inside of here. That's a parallelogram. We could map him out. Do you know what this angle would be? Down here in this bottom corner?
180 minus 124.
180 minus 124, like 56.
Yeah.
So then this
For
one's
sure.
also 56, and this is 124. You know, we could keep going around and trying to, and figuring what these are. Okay, makes sense. Good. All right.
Good.
So let's go down a couple more. Using proportional segments of transversals. Okay, so they have 3 parallel lines going on here across. I'm looking at this diagram in the box. 3 parallel lines, and these 2 are called what?
Transversal.
There's 2 transversals going through the parallel lines. Okay, whatever. They are saying this. They're saying AB is this length here, and BC is this length here, and EF and FG, right?
Yes.
Is this length the same as this length?
No.
No.
No. Look at those angles.
This one looks longer, right? This AB looks longer than EF, right? Is BC the same length as FG? No, they're not the same length, but here's what will happen. If you do AB's length over BC's length, it will be proportionate to EF over FG, right? So let's say that this is 2 and this is 4 and this is 1. What's this guy going to be?
2.
This guy is double what this one is, right? So this guy has to be double what the top one is. So this guy has to be 2. Does that make sense? They're in the same proportion to one another. They're not the same length, but they're the same proportion.
How do you know that?
Because the lines are parallel, and only because the lines are parallel. Does that make sense? Because your lines are parallel and you have transversals that go between them, you can set them up as a proportion. All right, you guys do this in art class when you do like 1 point perspective. You guys know what 1 point perspective is? This guy's called a vanishing point. Okay? Now, where are your parallel lines? You see the parallel lines at all in here?
ADBC.
It's AD, BC, WZ, XY, those lines going this way. And then they have the top of your windows go toward the vanishing point, and the bottom of your windows go toward the vanishing point, and that's where you cut them off at, right? So it's 1 point perspective. So we have our parallel lines are actually going up and down in this case, okay? Let's see some dimensions here. They have us labeling AB is 8 centimeters. So label that at the top here. AB is that top guy. Okay? Now, is the bottom also going to be 8?
Yes.
No. I don't know.
Is it a rectangle?
Is this guy going to be, it will, like the window
Yes.
is rectangular.
It
Yeah.
has to be, or it's weird.
Okay? You would think it has to be, but it maybe not. So let's say I'm drawing my window, and let's say my vanishing point is up here, okay? And I draw my line this way, and I draw this vanishing point to this way. Is this length going to be the same as this
so
one?
I was right.
No.
No.
So even though on the wall, no, just wait a second. This is where it's
Literally says
confusing.
on the paper.
This is where it's confusing. Even though on the wall, this top line, this top of the window frame is the same length as the bottom of the window frame, the way that it appears in the 1 point perspective, this bottom is going to be longer than this top, right? It depends upon where your vanishing point is at. Does that make sense? Okay? Do you see that this bottom length is longer than this top length?
Thinking about the picture.
Okay, so we're just thinking about the picture, not the actual like lengths of them. Okay, we're talking about the drawing, not the actual length. So in the drawing, she makes this top length 8 centimeters. Okay, does it tell what the bottom length is? No, but it says that DC. Oh yeah, it does say the DC is 9 centimeters. This guy is 9,
4.
and ZY is 5. They want to know what WX is. This top. Okay.
So it's going to be 4.5.
Okay, so we've got to figure out how to set up a proportion. We know that we can set up a proportion. But you guys understand why that top and the bottom are not going to be the same?
Yes.
Okay, so let's set up a proportion. How do you want to do this?
8 over 9 equals
Sure.
X over 5.
That's fine.
4.5.
Okay, 8 times 5 is 40 equals 9 times X, and you divide by 9. You guys are being very patient with this long problem. What did you say it was again?
It's 4.44, so 4.5. No. 4.
That would round down to 4 still. So 4.44 centimeters. In the image, in the drawing, she's going to make that length on the top there 4.4.
Well,
Okay.
it's already drawn.
Kind of, right? Yeah. Yeah, I guess. Sure. Okay. Good? Questions about that?
You know?
Last one. Okay, last one down here. This is the last thing that they say. Here are my parallel lines. They're going kind of up and down at a slant. This way, here's my parallel lines. Okay, these two guys are called transversals in between there. Okay, now there's one more piece of information that I know that I didn't know before. One more piece of information that I know. What's congruent? We know that those guys are parallel.
Mid segments
this guy right here, and this
Segments
guy,
in the middle.
those two things are the same. This 3y plus 8 and 5y, I don't know if that's plus 7 or minus 7. Can we look?
It's a line 7.
I don't know.
Oh no.
Oh, no.
Oh no.
Let's see. Oh, this building has bad vibes, you know? No, does anybody have their book with them?
No.
I gotta look and see.
I feel fine considering my situation.
I'm not just gonna really stress out.
Is that what Evan said?
Oh. What does he do? Scratch his skull? Yeah.
Did you just say
Scratch.
scratch?
Brooks.
I asked him how
What?
he felt today, and he
Brooks
said
is
something
just
about
like-
dying. He was like, I just want to be dead or something. I don't
He
remember.
fractured his skull. I'm like,
I just found out this
That
morning.
sounds
I saw on
very
everyone's
serious.
story
Yeah.
last night.
I
Rick
didn't
Eman,
realize
and I
that
was
what the
like,
pictures were.
did
Okay.
he die?
I was like, why are they?
Okay, last one.
Did he die?
This one, label him as minus 7. Minus 7, okay? Those two things are equal to each other because they have the tick
Ow.
marks, yeah? So let's deal with that first. Let's do 3y plus 8 is equal to 5y minus 7. What do you want to move?
Add 7.
Add the 7, sure.
Subtract 3.
Okay, and subtract 3y. Okay, so 15 equals 2y, no, 2y?
Yeah.
Divide by 2,
7 point.
y equals 7.5 or 7.5, sure. Okay,
How the heck did I get
find x and y, we're finding y. Okay, now, how the heck do we find x?
Uh,
Oh, 6x minus 5 equals 4x plus 3.
It doesn't say that they're equal though.
Well, because the
You gotta say
You're right, but it doesn't say that they're equal, but you're right. If these two bottoms are equal and we're dealing with parallel lines, then these two top ones have to be the same as each other because they're proportionate, right? If these two are equal, then these two have to also be equal. Now they're not all four equal to each other, right?
No.
But these two top ones are equal, even though it doesn't say, because the lines are parallel. If these two bottoms are equal, these two top ones are equal. So let's set those equal and we'll solve for x now.
4.
Okay? Minus 4x, plus the 5, 2x equals 8. X is 4. Beautiful. Okay? So, parallel lines make things a lot easier because you can just do straight proportions and it's easy. Okay? This should be kind of an easy section. All right? You guys have homework. Looks like this. I'm saying this because you're on video right now. And, yeah, there you go.
Why are you gone?